but you get a point. Now you understand stuff after this point. Right, so there are different kind of registers that we need to make use of in order to accept or make use of the external interrupt. Right, now we have established that we've got two interrupts. One is the int0 and then int1 on the ATmega328P chip. We can add the P if you want, but it's still the same family. So these interrupts, int0 is connected to pin 2 and then int1 is connected to pin 1, right, which is PD2 and PD. Sorry, int0 is connected to pin 2, int1 is connected to pin 3. Sorry, so int0 goes to PD2, int1 goes to PD3 or port D3. Now, first of all, the interrupt control register basically allows you to know how to trigger the interrupt. Now we're going to talk about that using the wide screen, so hopefully it's a lot more visible. If you remember correctly, the digital signal is like a square wave, right? Like. So it's similar to a clock. And so far what we've done is basically before we had the pull-up resistor and pull-up, and then we say when it goes down, do something. So we realize that we can also set it 0, and then we say when it goes up, do something. So before we had really, if this was our switch, we had a 1-0 approach to doing things, or 0-1 approach to doing things. Now, when we are triggering the interrupts, right, we can have different options to trigger the interrupt. One, when it's moving from 0 to up, so basically we call this the rising edge, rising, right? Or when it moves from a 1 to 0, we call this a falling edge, right? Falling edge. Or we can say when it is, so we have rising edge, falling edge, and then we can say when it is in a stable state 0, or when it is stable state low, or when it is a stable state high. So we've got the stable state low, we've got the stable state high if we want, but we may not actually use this because we've got the stable state low as a change. And we've got the rising edge, we've got a falling edge, or we can say any change at all, it should respond. So if it is a 1, if it is, so as soon as I make a change, it responds. And we are referring to the external interrupt or whatever signal is generating the external interrupt. In this case, we can use a switch as an example. I hope you understand that. The external interrupt that we are expecting to happen, when do we want to change it? We can respond to the change if, let's say, it's at a low level, that is stable state low, or if there is any change at all, or if there's a change on the falling edge, or if there's a change on the rising edge. So we look for some specific things on the external, and this is actually quite good at switch debouncing or switch bouncing, right? So those asking questions whether they have to use interrupts, you may have to rethink about that question as well, right? Okay, so at the moment we have a register that we say controls the state of whether we want to say the interrupt should we should respond to the interrupt at the low level or any of these 4 states, right? So you remember a register is just like a pebble in a bowl, right? We look at the state of the bowl to make a decision, and this is how we make use of 1s and 0s. So if we look at the external interrupt control register A, which is EICRA, this register controls that trigger. So we've got one for int0, and then we've got one for int1. So the registers are 8-bit wide, so we've got 0 to 8, and the upper neighbor is not in use. So the upper neighbor, we don't use it, but we make use of the lower neighbor. So the lower neighbor 0 and 1 is used to control interrupt 0, and then 2 and 3 is used to control interrupt interrupt 2, well, interrupt 1. So if you are using pin 2, obviously this is the register you are interested in, the register bits you're interested in. If you are using pin 3, this is the register bits you're interested in. One way of identifying it is 0 1 0 0. It starts with a 0, whilst the int 1 starts with a 1. So these are the pin combinations. If you are using pin 2, only pin 2, then a 0 in this particular register, 0 0 in this particular register means that your interrupt will respond to the low level. Now I'm going to make this clear to you. You are to use different interrupts also to show that different people have different sets of code, which means you really want to use something different in here. It's one way of making the code yourself, and when I ask for explanation, you will pull this information out to explain to me why you did what you did. So if the value, if we are using pin 2 as the interrupt pin, and the value on pin in this register, that's ISC01, ISC00 is 01, then it will respond to any change. If it is 11, it will respond to the rising edge. So the same goes for the other interrupt pin as well. So I give you an example of how to write the code. Obviously, you know this means EICRA equals EICRA, or one shifting this value in there. This is just an example. I don't expect you to copy and paste it for me. But if you understood the register code, you should be able to understand this one as well, because we've broken it down step by step to explain it. It's simply how you manipulate these registers. So the first one is we've thought about, okay, the signal that we are receiving, at what state do I want to respond to that signal? The other register we need to work with is the external interrupt max register, which is the EIMSK register, where you have, again, you have 8-bit. What I didn't point out is that the address of this register is actually address 69, and the address of the EIMSK register is address 38. So even if you wanted, you could modify the SRAM code to show you these the data in these addresses when you make a change, but we don't really care about that for this particular assignment. So you have 8 registers, 8 bits for the register. 6 of the bits are not in use. You are using only 2 for int 0 and int 1. Okay, so even though you connect, remember before you've connected a switch to pin 2, but you didn't use it as an interrupt. So at that point, you don't touch this register. But when you want to say, I want to use pin 2 as an interrupt, you need to enable this int 0, because pin 2 is connected to int 0. If you want to use pin 3 as a register, you need to enable this one, meaning push a 1 in there. So if you're thinking, what is a mask? Basically, a funny example of a mask is simply like you have your eyes, and you say, so this is just an example, hopefully it's not too creepy. So if you want to mask out a variable, so simply you cover that particular bit, so it's not seen. So basically, once you cover that bit, it's not seen. So meaning that you've got a mask covering it, so it means it's not in use. So the same time, so at the beginning, these registers are maxed. So basically, we are not using those switches, those pins as interrupt. So simply, if I want to use pin 3 as an interrupt, I've got this connected to pin 3, so I unmask it. If I want to use both pin 3 and pin 2 as interrupts, because I have 2 switches that I want to be responded to, then I basically unmask pin 2, which means they are use your alternative. Do not copy and paste this. Those who do not understand will copy and paste and not make much benefit of it. Right. So we're still on the external interrupts. We've made use of two registers. The first register tells us what mode we want to respond to, and the second register tells us whether we are actually using the interrupts, because if these marks are not set to 1, nothing will happen, as in it wouldn't respond to it as an interrupt. It will just be like a digital read, digital write function. Then you've got the external interrupt flag. So basically, at the moment, what we have done is the signal, we've decided what mode we're going to detect the interrupt on. We've enabled either pin 2 or pin 3 as an interrupt using the mask. Now we need to tell whether an interrupt has actually happened, right? So basically, it's going through its normal routine. If an interrupt happens, that's if those conditions that we had before are met, and pin 2 is the interrupt, then this flag will be set. It will keep 1 until that interrupt finishes executed, and then it will go back to reset itself. If we are using pin 3, this flag will be set when an interrupt happens. So as soon as this is the pebble in the bowl, right? As soon as there's an interrupt here and the previous conditions are already met, the compiler, the processor will say, what is the actual interrupt service routine I need to run? So it will just jump to run the interrupt service routine. So those are the registers that we need to set, and basically I've got a bit of code here that I will explain to show you how interrupts work.